Welcome to the third revision lecture of the foundation course of Bakliwal Tutorials-IIT. In this, we'll be dealing with subtopics, limiting reagent, percentage yield, methods to represent concentration of a solution. First, we'll be dealing with limiting reagent. As the definition specifies, which is less in ratio and will get consumed up completely during the reaction and will govern the amount of the product formed. Now, we need to explain this in a better way. That is, to take a reaction N2 plus 3H2 gives 2NH3. Now, please remember, this is called balanced equation. Please remember, why do we call it balanced? Because the number of atoms on either side are equal. Atoms on reactant side is equal to product side. Now, please remember, generally we mention the subscript gas, gas, and gas. From the balanced equation, it is quite evident that 1 mole of this is reacting with 3 moles of this to form 2 moles of ammonia. That means the ratio in which they react is 1:3:2. Now, technically, if I mix 5 moles of this and 15 mole of this is very important. Now, you can see this will be formed how much? We will discuss about that. Now, technically, you can see 1 mole of this to react completely will require 3 moles of this. So, 5 moles of this will require 15. So, the answer will be, without any hesitation, 10 mole ammonia. Now, Bharat Desh, Garib Desh, if you have, let's say, third condition, that is 5 mole of this and 10 mole of this, then the problem starts. What happens is, we have to calculate now. See, now 5 moles of this from the balanced equation, 1 mole of this is reacting with 3 moles of this. Yes or no? No. 5 moles of this will require 15 mole of this. That means this will never react completely. This will never react completely. This is very important. Try to understand. 1 mole of this to react completely will require 3. So 5 will require 15 to react completely. Please remember, this is only 10. This is only 10. So, ये implication है कि भैया 5 mole N2 will not react completely. Very important. Now, we'll see ulta. 3 moles of this will require 1 mole of this. That means 10 mole of this will require 3.33. So, this 10 mole reacts completely. Reacts completely. Very important thing. We have done it by ratios. We haven't done anything new. ध्यान में रखिए. Completely. Now you can see, I'll explain it once again. 1 mole of this to react completely will require 3 moles of this. That means 5 moles of this to react completely will require 15 mole of this. That means if we have 10 mole of hydrogen, 5 mole N2 will never react completely. Now, the next part. Technically, you can see 10 mole of this will require to reacts completely, and it will require 3.33 mole N2. That means 1 minus 3.33 will give you 1.67 mole N2. N2 will be left unreacted. A point to be remembered. A point to be remembered. Please remember, 10 mole of this will require 3.33 N2. That means 1.67 N2 will be left out. Now, By definition, who is getting consumed up completely? Please remember, by definition, who is getting consumed up completely? 10 mole this. So in this example, who is the limiting reagent? 10 mole H2. That means the amount of ammonia formed will always be controlled by, in this scenario, will always be controlled by hydrogen. Please remember, because 5 and 10. Please underline this word less in ratio. आप में से बहुत लोग क्या करेंगे, लेस इन नंबर लेके N2 को 5 मोल आप लिमिटिंग रिएजेंट लिखोगे, आपको एग्जाम में पप्पी मिलेगा. तो ध्यान में रखना ये बात. Please remember, you should always see the ratios, and which is less in ratio will always control the amount of product formed. That means here the answer will be 10 into 2 by 3 mole ammonia. 10 into 2 by 3 mole ammonia. अभी बच्चे बोले सर कैसे आ गया, एकदम जादू कर दिया आपने. सिंपल बेटा, यूनिटरी मेथड. 3H2 when reacted completely is giving 2 ammonia. That means 10 mole of this will give 10 into 2 upon 3. Yes or no? Now, please remember, once we have learned the technical example, field type 1, Gauss type example, please remember 1 vada and 1 pav will give 1 vada pav. Now, 3 vada, 4 pav will give how many vada pav? You can see from the example, the top one, this is the balanced equation that which we need to appreciate, otherwise the answer will be wrong. First we have to know the balanced equation. Now from the equation it is evident that 1 vada is going with 1 pav to form 1 vada pav. That means 3 vada 4 pav will form, please remember, 3 vada pav and 1 pav will be extra. So in this case, who is getting consumed up completely? Please remember, 3 vada is getting consumed up completely. So who is the limiting reagent in this case? This guy. So please remember, this is the limiting reagent. Now, नहीं sir, हम वड़ा पाव खाने वाला आदमी नहीं है, हम we eat a sandwich. So please remember, we take one more example. 2 bread slices and 1 cheese slice will make 1 sandwich. 8 bread slices and 3 cheese slices will make how many sandwich? Now, please remember, as I've stated earlier, this is the balanced equation. Once we know this, it says that 2 bread slices will go with 1 cheese slice to form 1 sandwich. That means using this we can form 4 sandwich. Here we can form only 3 because this is less in quantity. So please remember the answer will be, 3 sandwich and 2 bread slices extra. Please remember, who is the limiting reagent? In this case, the limiting reagent will be cheese slice because it is getting consumed up and it is controlling how much amount of or how many sandwiches are being made. Please remember, this is very important concept, limiting reagent. A reagent which is less in the ratio. In this case, we have taken N2 plus 3H2 gives 2 and H3. The balanced coefficients were 1, 3, 2. The ratio was 1, 3, 2. That means if you take 5 mole on 10 mole will react completely because it requires only 3.33 mole N2. That means in the process 1.67 mole N2 will be left. So please remember, this is our limiting reagent. This is called excess reagent. This is called excess reagent. Hope these. Now, second example that which we said Gauss type. 1 vada 1 pav will give 1 vada pav. 3 vada 4 pav will give. Please remember, don't put any danger number. It is 3 vada pav and 1 pav will be excess. And who is the limiting reagent in this case? None other than vada. Now, hope this example helped you to understand limiting reagent better. Let's say we have an equation. calcium carbonate solid on heating will give calcium oxide solid plus CO2 gas. If you remember the weights or atomic weights or the molar masses properly, it will be 100, 56 and 44. Please remember, if I take 100 gram solid, 100 gram solid and I am heating, I am getting 56 grams solid. That means 44 grams of CO2 has escaped from the solid that which we have started with. Now, if you see, if we get 44 grams of CO2, if we get 44 grams of CO2, this is called theoretical yield. This is called theoretical yield. Now, if the question says that 100 grams of calcium carbonate is heated and 33 grams of CO2 is observed. 33 grams of CO2 is observed. That you can understand the actual yield. This will be the actual yield. Please remember that which people have observed. That means percentage yield is equal to 33 upon 44 into 100, that is equal to 75. Please remember, in the earlier thing, we have explained that N2 plus 3H2. There is one more equation. If you remember, N2 plus 3H2 gives 2 ammonia. If I take 5 moles of this and 15 moles of this, I'll end up with 10 mole of this. This will happen only if the system is 100% efficient or percentage yield is equal to 100. Otherwise, proportionately, the product will also decrease. This is a very important concept because if you see in any industry, if you increase the percentage yield by, let's say, point not some decimal, it will make a difference of crores to the company. That's why people emphasize on this percentage yield of a reaction of the process. Hope you understood how to calculate percentage yield of a reaction or process. Now we'll talk about methods to represent concentration of a solution. The first one we'll be dealing with is molarity. Please remember it is represented by uppercase M. How it is written? M is equal to moles of solute upon liters of solution, which can be rewritten as weight of solute in grams upon molar mass of solute into 1 upon liters of solution. Please remember this term here is indirectly specifying number of moles. This is very important. In the earlier session, we might have discussed how to calculate moles of a substance. In that, we have specified we can use mass for calculating number of moles. Now, for example, if we have 49 gram H2SO4 is present in 500 ml of solution, what is its molarity? Please remember, you have to calculate the molar mass of solute. In this case, it is H2SO4. Please remember, we need to remember few atomic mass, that is H2SO4 is 2 into 1 plus 32 plus 4 into 16, which is equal to 98 gram upon mole. Now, if you plug that in the formula, M is equal to 49 upon 98 into 1 upon 0.5. Please remember, here it is liters. So this was in 500 ml. So we have converted this. So we have converted this into 0.5 liter. That is equal to 1. So the molarity of solution will be 1. Please remember. Now, from this, what we can decipher, if X molar solution is present, then it has X mole solute in 1 liter solution, or X by 2 mole solute in half liter solution. Both representations are same. We can use this to predict or to calculate the molarity of a solution. Please remember, molarity is one of the methods to represent concentration of a solution, and it is represented by capital M, and the formula is moles of solute upon liters of solution. Now, in this, if you remember, if you cross multiply, please remember, we can calculate moles of solute. We can rewrite the formula as moles of solute is equal to molarity of solution multiplied by volume of solution in liters. This is very important. Solution in liters. This is very important, and you need to remember this. These 2 points are important. First one, the formula moles of solute upon liters of solution. Very important formula. Now, once we are familiar with molarity, we'll go to the next concentration that which we need to remember, that is molality. Please remember, this guy is represented by lowercase m, and the formula is moles of solute upon kgs of solvent. Remember the change, the denominator has changed. It is kgs of solvent. Now, the question says that 45 gram glucose C6H12O6 is present in 250 gram solvent. What is the molarity? Now, please remember, C6H12O6 is 6 into 12 plus 1 into, plus 12 into 1 plus 6 into 16, that is equal to 180 gram upon mole. Now, we should plug it into the formula. M is equal to weight of solute is 45 gram upon 180 gram upon mole into 1 upon, please remember, this is in here, the solvent weight is in grams. We need to be representing it in kgs. So it will become 0.25, that is equal to 1 molal. Now, this is one of the methods to represent concentration. Quite familiar will be molarity. The second one will be molality, which is represented by small m. Both have same denominator. Both have same numerator, that is weight of solute. Now, I'm very sorry. Please remember molality and molarity both have same numerator, that is moles of solute. Both have different denominators, liters of solution and kgs of solvent. Now, once you are more comfortable with molality, we should go to the next one. That is, there is a small technical problem here, but still we'll try to explain it. Please remember, mole fraction is represented by a formula XA is equal to mole of A upon total number of moles. For example, if I have a gaseous mixture with me, gaseous mixture which has 5 mole O2, 6 mole N2, 4 mole carbon dioxide and 5 mole carbon monoxide. If you can add these things, please remember the total number of mole is 20 mole. Now, in the mixture. Now, I want to calculate mole fraction of O2. Then it becomes X O2 is equal to mole of O2 upon total, that is equal to 5 upon 20. If you want to calculate X of N2, it will be 6 upon 20. If you want to calculate moles of CO2, that will be, mole fraction of CO2, it will be 4 upon 20. If you calculate mole fraction of CO, that will be 5 upon 20. If you are good at observation, आपको अभी तक ये पता चल जाना चाहिए, the sum of mole fractions, the sum of mole fraction will always be 1, will always be 1. Now, please remember, these are the three methods that which we have done to represent concentration of a solution. First one, molarity, and mole fraction. Please remember, molarity is represented by capital M, the general one, molarity, this one by X. Now, we are done with methods to represent concentration of a solution.